In question 2, we're told the time period of a satellite in a circular orbit about a planet is proportional to the radius to the power 3/2. We have a satellite in a low polar orbit with a time period of 105 minutes and a radius of 7370 kilometers. In A part 1, we're asked to find the height above the surface of the Earth in kilometers of a satellite in a geosynchronous circular orbit. Well, time period is proportional to radius of orbit to the power 3/2, so the time period for the geosynchronous orbit over the time period for the polar orbit will be equal to the radius of the geosynchronous over the radius of the polar to the power 3/2. Putting in the values, this gives the radius of the geosynchronous over the radius of the polar, given by this expression. We can then rearrange, and we get a radius of 4 to 200 kilometers. We're asked for the height, not the radius. The height above the surface is the radius of the orbit minus the radius of the Earth. This is given on the formula sheet as 6370 kilometers, giving a height above the surface of 35900 kilometers. In part 2, we're to find the centripetal force acting on the polar orbiting satellite if it has a mass of 650 kilograms. Well, centripetal force is given by mass times radius times angular velocity squared, and the angular velocity omega is 2 pi over the time period, so we can substitute in to give this expression for the centripetal force. We can then put in all the values, not forgetting to convert the time period to seconds and the radius of orbit to meters. This gives 4760 newtons. In B, we're to compare the principal features of a geosynchronous and a polar orbit, explaining the consequences for possible uses of satellites in these orbits. Well, a low polar orbit travels around the Earth many times a day, passing over different parts of the Earth's surface on each orbit due to the Earth rotating beneath it. It's quite close to the Earth, allowing detailed monitoring of the surface. It can be used for monitoring the weather, for land use, or for spying, with a wide range of orbits being possible to suit the use. A geosynchronous orbit is always above the same point of the equator, meaning satellite receivers can be fixed pointing in one direction, making it suitable for transmitting television signals to many homes. It's a long way above the Earth's surface, meaning the signal can be received over a large area.